Okay, this is going to be the first video for Trig Graphs. All right, I want to tie this back in to the unit circle. Okay. All right, we're going to talk about how these actually graph on a grid in a little bit. Okay. So one thing we're going to talk about is we're going to use the axis points to help us find basically the values of the sine, the sine and cosine function. So for let's start with sine. Okay, so sine. Okay, all right. We use 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay. All right. What are those values? Okay. Well, they're 0. At pi over 2, it's 1. So these are the angles. And these are the values, okay? Pi at 0, at 3 pi over 2 it's -1, and at 2 pi it is 0, okay? So all I'm doing is just going through, boom, 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 easy, okay? Now, all right, this right here is called a period, okay? Period of the function, all right? It's how long it takes to cycle, all right? Length of cycle, all right? Now, the typical sine function and cosine function, this is something I want you to know, sine and cosine have the standard period is 2 pi. How long does it take to cycle back through the values? You can see it goes, starts at 0, 1, 0, then goes to negative, then comes back to 0, okay? Now, what we want to do is we want to graph two periods, okay? So how does that work? All right, do a little line right here. I'm going to keep those values going, okay? All right, so it will end up being 5 pi over 2, all right, then 3 pi, then 7 pi over 2, and then 4 pi, okay? All right, as you notice the pattern in the fractions, pi over 2, pi, 3 pi, 2, you notice that these are the fractions are odds, okay? And then the values. So we cycle one time through, boom. Now I'm going to go again. So then that's 1, then that's 0, then that's -1, then that's 0. As you can see, it goes to, after it passes through the negative, it goes to 0, then back through. Okay? Now cosine. All right? Cosine. Let's go through the same thing. Angles, values. Okay? All right? So same deal. 0, pi over 2. Pi, 3 pi over 2, 2 pi, that's one cycle, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi. Okay, now the values are different. Cosine, first one's 1, then it goes to 0, then it goes to -1, then it goes to 0, and then it cycles back to 1. All right, if I keep going, it would be 0, it would be -1, it would be 0, and 1. Okay? So it keeps on cycling through like that, okay? Now, all right, what would those graphs look like, okay? What would those graphs look like, all right? I'm going to duplicate this, so we got the chart on the next page, okay? As soon as my page will respond. All right, great. All right, we'll do one more duplication. Hopefully that doesn't take too long. All right, so what we want to do is I want to show you what these would look like if you were to actually graph them on an XY axis, okay? So this is page 2 now, great. All right, now let me take out the unit circle real quick. All right, we don't need that anymore, okay? So the big thing you want to commit now, all right, is you want to commit these values. You could have those on a piece of paper, okay? The values are more important than the angles because the angles are going to change, and we're going to get to that in a second. So if I were to graph the sine function, all right, here's the sine function, all right? So now I'm going to graph it this way. 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, made the thing too short, 7 pi over 2, and 4 pi. Okay? All right? These are the angles, these are the values. So I'm going between 1 and negative 1. Okay? All right? So, this is the sine function. At 0, I'm at 0. At pi over 2, I'm at 1. At pi, I'm at 0. At 3 pi over 2, I'd be at negative 1. At 2 pi, I would be at 0. At 5 pi over 2, I'm up here at 1. At 3 pi, I'm at 0. Right? At 7 pi over 2, I'm at negative 1. And at 4 pi, I'm at 0. So this is what the graph looks like. It's a wave. Okay? It's a wave. So that's what that looks like as a base function. If you do the same thing for cosine. Okay? 1 and negative 1. All right, pi over 2. Pi. 3 pi over 2. 2 pi. 5 pi over 2. 3 pi. 7 pi over 2. 4 pi. Okay? So if I was graphing cosine, at 0, I'd be at 1. At pi over 2, I'm at 0. At pi, I'm at negative 1. 3 pi over 2, 0. 2 pi, 1. 5 pi, 0. 3 pi, negative 1. 7 pi, 0. 4 pi, 1. So it looks like this. A little bit different. Now, this actually keeps on going both directions into the negative angles, which we'll talk about later. Okay? All right? This goes, same thing for this one, okay? Now, those are the base functions. Do you need to know how to graph the base function? No, the big thing you want to focus on are these values, okay? Because the angles are going to change as we put more numbers in, okay? So, I'm going to go ahead and erase this, and I'm going to duplicate this a bunch. All right. So let's talk about how some basic stuff can change your graph. Okay. Let's do 2x minus pi over 2. Okay. Let's take a look at this one. And let's say we wanted to graph 2 periods. Okay? That was what the directions were. Now, in this virtual world, for the most part, we're just going to ask you to write the tables and match graphs. But I want to teach you how the graphs are made so you understand the concept. Okay? All right? So, in the interest of doing this, I'm going to go ahead and duplicate this page real quick. In the interest of doing this, I want to show you a comparison, all right, with the sine function, okay, and talk about how do these things affect our numbers, okay. Make sure I got, all right, what we got 3, I got some on 4, great. Okay, so I want to erase, because we're working with cosine. I want to erase cosine for a second. And then I want to explain sort of how it's a great pattern, okay? What you're going to do, all right? Always start, I'm going to write the directions here. Start with the values, okay? So the values at the start will never change, okay? All right, for sine, all right, there's the angles, here's the values. So it always starts with 0, 1, 0, negative 1, 0. I'm going to put this dot because that's what the period starts over. So it's going to start back here, 1, 0, negative 1, and 0. So a good thing to know, you have 5 and then 4. Well, why is it 5? Because this goes back to start, so and then it keeps on going, okay? So that's the way it's going to look, okay? All right, now, let's talk about how you figure out the angles. All right, what you do to figure out the angles is I take the inside part of my function and set it equal to 0, okay? I'm going to set it equal to 0. This unit is a battle of fractions, and you got to get good at the fractions, all right? So what I would do is add pi over 2 to both sides. That's 2x equals pi over 2. And then I would divide each side by 2. Okay, so that's going to be x equals pi over 2 divided by 2. You got to think about flipping that. Okay, it's going to be pi over 4. Okay, all right, so remember, when you're doing fractions, times, this is like 2 over 1, becomes 1 over 2, right? That becomes 4, okay? So that's how you would get that, all right? So, so what you want to do, you want to start with the values. Maybe I'll write directions down here instead. All right, we want to put the values in, okay? Then we want to take the part inside, set it equal to 0, and solve. This is your first angle, okay? It is also something called the phase shift, okay? And what phase shift does is it separates it, or it moves the graph, okay? It shifts it, all right? So pi over 4. The next thing you want to do is find the period, okay? How do we find the period? Okay, so this is how we get the phase shift. Okay, this is how we get the phase shift, and we get the starting angle. We get the start. Okay, to get the period, I take the number, okay? I take 2 pi, and divide it by the number that's in front of x. Sometimes they'll say theta, depends on the graph, okay? So in this case, all right, I've got a 2. So my period would be 2 pi divided by 2, which would be 1 pi. Okay, that's your period, okay? Then what you want to do is take the period and divide it by 4. This is every single time. Regardless, actually, you know what? I'll even change this. I'll make this a 5 so we're not confused. All right, so, all right, I've got, I would take my period then and divide it by 4. So 1 pi divided by 4 would be 1/4 pi. Okay? All right? Now, what do I do with that amount? Okay? What this is my interval. Okay? All right? So my interval is also 1/4 pi. Okay? Now, what does that mean? That means that to figure out my angles, all I got to do is keep adding 1/4, and it would get my angles, okay? So, what I want to do, instead of from a battle of fractions standpoint, this is pi over 4. An easier way to write that is it's just basically 1/4, okay? And we're going to add 1/4 pi, okay? So that's going to give me 2/4, basically pi. Well, what's 2/4 pi reduced to? It reduces to pi over 2. That's what would go there. Then I take this 2/4 pi, and I add the 1/4. Well, what's that going to be? 3 plus 1, 3/4 pi. Okay, then I do 3/4. Add 1/4. What's that going to give me? 4/4 pi. Well, what's 4/4 pi? 1 pi. Okay, then I do 4/4 pi. Add 1/4. It's going to give me 5/4 pi. Okay, all right, then I'm going to take 5/4. Add 1/4. That's going to give me 6/4 pi. Well, what is 6/4 reduced to? 3 pi over 2. Okay, then what do? Take 6/4 pi. Add 1/4. This is 7/4 pi. Do you need to write all this stuff down? No. If you can do the calculations in your head, great. So this is 7/4 pi. Okay, then I do 7/4 pi. Add a 4th. That's going to be 8/4 pi. What does that mean? 2 pi. I'm going to do 8/4 pi plus 4th gives me 9/4 pi. Okay? Boom. Got all my angles. Okay? Got all my angles. All right? Now I'm going to duplicate this real quick. So that's how we end up getting our angles. All right. I'm going to talk about something that's going to affect the values here. Okay. All right. 1 second. Okay, let me go back to this screen. Okay, so this part right here, this is called the amplitude. Okay, it affects the values. And what I would do with the amplitude is I multiply by the values. So what I'm going to do is I'm going to multiply everything by 5. So this would still be 0. This would be 5, 0, negative 5, 0, 5, 0, negative 5, 0. So these original ones don't matter. Okay, all right, all right. So now, I'll just erase this. Okay, now, how do we end up making our graph? Okay, I got my angles, I got my values. All right, big thing is to write the values in first, and then figure out your angles. All right. Now, okay, this is where you got to have a little bit of knowledge about how fractions work. Okay, I'm going to always start out with the concept of 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, and 4 pi. Okay? Now, as you can see, so Mr. Evans, we got fourths here. Okay? You can see little fourths. Half of a fourth is, or half of a half is a fourth. So I'm going to cut the halves. So that's going to be basically a quarter pi, cut 3/4, cut 5/4, cut 7/4, cut 9/4, 11, 13, 15. And as if you notice, look at them. They're all odds. 1, 3, 5, 7, 9, 11, 13, 15. Okay? All right? So, what am I going to do? At a quarter pi, I'm at 0. That's a quarter. At a half pi, I'm at 5. 1, 2, 3, 4, and 5. Wait, 1, 2, 3, 4, and 5, sorry. So here. All right. At 3/4, I'm at 0. At 1 pi, I'm at -5. At 5/4, I'm at 0. At 3/2, I'm at 5. Okay. At 7/4, I'm at 0. At 2 pi, I'm at -5. And at 9 pi over 4, I'm at 0. So I actually didn't have to use all those. So here's what my graph looks like. Boom. The sine function. What's happened? It's shifted and it's been stretched. Okay. I would like to do the same thing with now a cosine example. Let me go ahead and erase this. I'm going to erase all this stuff. I'm going to erase all this stuff. Let's do a whole nother example. I'm going to do one with the negative. All right? So we sort of get the concept. Actually, maybe let's do a positive one. All right, let's do a positive. We're going to graph 2 pi. All right, so let's do a cosine. Let's say I got y equals 6 cosine. Let's say say I got this. Okay? Did I do 4 last time or is it? Okay, yeah, let's work with this. All right, so where would I start? I'm going to start with my cosine values. I'm going to start with the cosine values. What are they? The values are going to be a little bit different. 1, 0, -1, 0, 1. Got to know that pattern, then it starts over again. Okay, as you can see, it cycles back through. 0, -1, 0, 1. Okay, going to start with that every time. All right, now, what am I going to do to figure out my angles? I'm going to take this, set it equal to 0. Okay, whatever's inside, set it equal to 0. I'm going to add 2 pi. Add 2 pi. Okay, that's going to be 4x is 2 pi. Divide by 4. I got x, that would reduce to pi over 2. So what does that mean for me? Okay, look at the previous example real quick. All right, so what that means is my first angle value is going to be pi over 2. Okay, first angle value will be pi over 2. Now, what I'm going to do is I'm going to find the period. Okay, this is also my phase shift. All right, so what I want to do is I take the period, it's 2 pi, and I'm going to divide by the number that's in front of x. Number in front of x is 4. So that's going to be pi over 2. That's sort of a coincidence that we've gotten the same amount. So the period is pi over 2. Okay? Now, what I want to do to get these amounts is I want to divide, all right, so so that's my period, pi over 2. I want to find the interval. Okay? The interval is going to be the period divided by 4. Okay? Period divided by 4. So it's going to be pi over 2 divided by 4, which will end up being pi over 8. Okay? Will end up being pi over 8. All right? All right, so that's going to be my interval. Okay? Now, what I got to do is I got to do a little battle of fractions. Maybe I would do this on a separate sheet of paper. Okay? I'm going to add pi over 8 to each one of these. Okay? So that's basically 1/2 plus 1/8. I don't need to worry about the pi's. They're always going to be in there. Okay? So I need to get a common denominator. I would need to multiply by 4 and 4. So that's 4 over 8 plus 1 over 8. Okay? It'll give me 5 over 8. Okay? So the next one will be 5 over 8 pi. Okay? 4 over 8 plus 1 over 8, 5 over 8. Okay, then I want to do 5 over 8 plus 1 over 8. Gives me 6 over 8. Well, what does that reduce to? 3/4 pi. Okay, then 6 over 8 plus 1 over 8 is 7 over 8. 7 over 8 pi. 7 over 8 plus 1 over 8 equals 1 pi. It equals 8 over 8, which 8 over 8 is 1 pi. And I do 8 over 8 plus 1 over 8 is 9 over 8. That's 9 over 8 pi. Then 9 over 8 plus 1 over 8 is 10 over 8, which would be 5/4 pi. Okay? Then 10 over 8 plus 1 over 8 is 11 over 8. Okay? Pi. And then 11 over 8 plus 1 over 8 is 12 over 8, which would be by 2, 6, 4, 3 halves pi. All right, and that's how I got my value. So it's a battle of just adding 1/8. What I would do is don't reduce the fractions so you write them over here, because it makes it easy once you get the original common denominator to do that. Okay, so that's the fraction part. Now, what I want to do is I want to go ahead and graph those. Okay, I'm going to graph this now. Erase all this stuff. Actually, you know what? I'm not going to erase that part. I'll erase the fractions. I'm not going to erase the intervals. Okay. All right. So let's start. Okay. Now, since I have this 6 here, I'm going to multiply all these by 6. 6, 0, -6, 0, 6, 0, -6, 0, 6. Okay? All right? So, once again, I'm going to cross those out. I'm going to start with 0, pi over 2, pi, 1 pi, 3 pi over 2, 2 pi, 5 pi over 2, 7 pi, 3 pi, 7 pi over 2, and 4 pi. Okay, now, all right, what I want to do, all right, now you can, you see that I have eighths. Okay, now how did I make quarters? I made quarters by cutting the halves. So 1 quarter, 3, 5, 7, 9, 11, and so on. Okay, now as you can look at this, where is my starting part? Pi over 2, where's my ending part? So I know I'm going to be between here. Okay, all right. So drawing a graph like that tight, okay, one thing you should always look at is where am I going, okay? All right, so maybe what I should do instead, okay, I'm drawing it that big. Okay, and this is important once you shift down into eighths. You look at, well, where am I, what's my first value that I get to? Okay, I get to 0 and then pi over 2. Then I go to, then I would go to pi, and then I would go to 3 pi over 2, and then I go to 2 pi, all right? Why don't I do the big thing? Because I already know that I'm only going in this spot, okay? So, I would divide this up by quarters. This is still 1 quarter, 3 quarters, 5, and 7, okay? Now, how do you go smaller than that, okay? All right, how do you go smaller than that? How would I go to an eighth? Cut these amounts in half, and I do it below. 1, same concept, 3, 5, 7, 9, and 11. I don't need to go any smaller than that, or further than that, because that's what I have there. Now I'm graphing these values. At pi over 2, I'm graphing 6. At pi over 8, I'm graphing 0. At 3/4 pi, I'm graphing -6. At 7/8, I'm at 0. At 1, I'm back up at 6. At 9/8, I'm at 0. At 5/4, I'm at -6. 11/8, I'm at 0. And then 3/2, I'm back up at 6. So here's what my graph looks like. Okay? All right? Now, this is a little bit of a longer video. Okay? All right, so what you can do, okay, I'm gonna go ahead and just put the ones I'd like you to practice up on the board, and we'll go over them in class, okay, all right. So what I would like you guys to practice on your own, okay, go ahead and practice sine of, let's say, 4x minus pi, and let's say I want you to do 8 cosine of x, 2x minus pi over 2. I don't think that's the same problem, okay? So I would like you to practice those two, okay? I will put the graphs, I will work these graphs out for you, and then I will put them, we'll do them in class, okay?